Again, to discuss some more thing about, so last class I have shown you the some other various functionalities are available under the data frame. How can you retrieve particular column? How can do the some retrieve particular based on the various condition? Okay, so this thing we had discussed in the last class. So here I want to discuss some more thing about the indexing and some other conditions are there. Also data alignment. This I will discuss now. Okay, so yes, indexing this I have discussed also from the previous lecture. So if you want to identify a particular column, you are positioning, you are giving some number for the corresponding column and the corresponding row. So this is the zeroth column, one column, second column, third column, fourth column. The zero row index, so zero index, one index, two index, third index, fourth index, like this way. So if you want to do anything with the column and name, you can identify the particular column and particular name in the index format. Okay. So if in the Excel sheet or if you have already created a one data frame where no there is no index, only the name and ages are available, you can create the index also. So already this step I have already shown you how can you create the column and column values using the dictionary format, name, key values. These are the values you are putting. Age is a key and 20, 30, 25, 30, 30. These are the key values. In this way you can create. So in the last class I have shown you just if you write the pg.data frame within bracket data, then you are creating a data set where these two columns are there, name and age and values are there. There is no index. If there is no index, by default it will be considered as a 0, 1 and 2. But I want to give the index with a different name, suppose A, B, C. So in the under the data frame we are passing the data, and also index is the one argument. In index you have to write the values. What are the values you want to put in the index? A, comma B, comma C. This you want to give as the index name. Okay, so A, comma B, comma C, like this, so you can give the index name. So if you want to give the column, I told the column is equal to the column values you have to pass. You want to give the index is equal to index name. This way you have to write. Again, if you want to add some other index already, you have created one data frame where A, B, C, three index are there. Already A, B, C's are available. Now we want to change the index. So you can write the new index is equal to new index. So what are the index you want to give? A, B, D, E. Instead of A, B, C, you want to give the A, B, D, E. So again, you are want to do reindexing. So df dot reindex you have to apply. Reindex operation you have to apply. In reindex you have to pass the new index values A, B, D, E. So the C index corresponding to C, what are values are these you cannot see in the new data frame. The data frame with the after reindexing. The new data frame name I have given as a df underscore reindex. And if you want to see the data frame, the C column will not be there because I have given as index name new index A, B, D, E. So C column will not be there. D and E column will be added, but corresponding to D and E, there are no values. There are no values because I have not created any data set based on the D and E index. So corresponding to D and E index, there will be an N value, not a number value will be there. As there are no number corresponding to those index, so it will be display like this way, and like this way it will be displayed. Okay, in this way you can create your own index also. If you create the index sometimes, so it may happen there will be a store of the NaN value. So now if you want to delete those NaN, how can you do that? This I've already discussed in the last class. Drop Na you have to write the drop NA. So drop NA you have to write, then those column will be deleted. Now if you want to, I told that if you want to delete particular column, okay, either it is NaN value or any other value, but I want to delete a particular column. So you have to write the drop within bracket age is equal to axis is equal to column. That means the age this column I have to delete. Age is the column, right? So drop age you have to delete and axis column. The column wise all the age values will be deleted. So if you have to write the column, then you have to write age comma the column name you have to write, and axis is equal to columns you have to write because age is your column and column wise it will be deleted. Now come to the data alignment. Data alignment, if you want to have the two different data frame, you want to mix two different data frame, then there will be an AN value. You have to mix the data frame based on the indexing. So that is called the data alignment. If the same index values are not there in both the data frame, there will be an AN value. So that means that when you add both the data frame and both the data frame and the index are not same, when you create the new data frame, the it will be mixed up the both data index. Okay, I'll show you now. Suppose here the A, B, C, three columns are there. Here A, B columns are there, and D is the different columns are there. So now, if you want to mix up both these column values and these column values, then you have to do the alignment. Okay. Suppose here three rows are there and three columns are there. A, B, C. Here three columns are there, but the C and D are the different, and the two values are there. So when you mix up those values, so if suppose correspond, so five more index will be created. Okay, so five more index will be created, and corresponding to these two index, these two will be suppose 4 and 5. Suppose in 4 and 5, C values are not there. So C columns will be added, but this 4 and 5 index, C values will be NN. Okay, like for the D column will be also added. Corresponding to D column will be there for 4 index, and the D column values are there for 4 index and the 5 index. Okay, that's why for under the D column, the 0 index, 1 index, 2 index values will be NN. So vertically it will be added and it will align the indexing or all the values. Okay. So if you write df align comma the new df you are creating with alignment you are creating. So the df is equal to align df1 dot align df2 fill values dot whatever values will be there, this you putting as a NaN. Here what we are doing, uh, here we are adding the D column in the DF1 and we are doing some operation, the alignment operation. So earlier the D column is not there in the first DF. Okay, so D column is added from DF2. That's why I have written. So DF2 is aligning with respect to DF1 is aligning with respect to DF2. The DF1 dot align DF2. Okay, so from DF2, that D column will be added in the DF1. As in the DF1, these values are not mentioned, so then NaN, NN, NN will be mentioned here. Again, you have to align the DF2 based on the DF1. So C column will be automatically added. In the C column, three values are there. That's why the three row will be added and three row NN will be there. And corresponding to index 2, no values are there in the DF2 for A and B and D. So these will be also NAN. I think it is clear for you. So when there are the two data frame and the two data frame, some common and the uncommon column name will be there. You can add both all the column name in both the data frame and you can do some alignment operation. Okay, so ABC are already adding in the first data frame, ABCD are also added in the second data frame. Based on the first data set, the values will be entered into the new column. Based on the second data set, the values will new column is added. If added, it will be filled with the NaN value. I think it is clear for you how can you do the data alignment. So if you have some values, you can in the data frame you can operate with the some you can put some rank position also. What we can do here, I'll tell now. So here, suppose the animal and the number of legs, there is a one data frame we have created. The fox have number of 4 number of legs, and kangaroo 2 number of legs, deer 4 number of legs, spider 8. The snake there are no legs. That's why the values are stored as a NaN. Okay, so in this way I can create the data frame. Now if I want to do some rank operation, already created the data frame. So this is the data frame. Now want to give the rank based on the number of legs. How can you do this kind of the operation? So here you can write if the no, one more column I am adding this the this is related to rank. Okay, so if you write the column the number of legs you want to do the rank operation on the number of legs column. So the df number legs dot column dot rank. So the default rank is added here. So what is that? This if the number of leg 4, the rank will be 2.5. If number of leg 2, the rank will be 1. If number of leg 4, rank will be 2.5. Number of leg 8, number rank will be 4. And if there is no leg, NN. This I'll tell how we are doing this or how it is stored as a 2.5. This you can tell. If 2 means 2 is the minimum number of legs, that I am giving as a 1. Okay, but in here also 4 is there and 4 is there. And how rather giving the 2 rank I am giving as a 2.5 here 2.5 here and here I am giving the rank as a 4. I am not giving the rank 3. How we are doing this operation this I will tell now. But where the maximum rank means based on the default rank the maximum rank can be created. Okay, the rank the colon method is equal to max. We are doing some default rank after that from the default rank they are doing some max operation. So 2.5 to rather setting the 2.5 we are say round we are doing the round of 2.5 as a 3. 1 is same as 1 again 2.5 is rank as a 3 again 4 is rank as a 4. Okay, so whenever the point decimal number is point integer number is there this will be ranked as a, the higher number. Okay, and if so this first this rank will be created based on this we can do these two operations. Okay, so wherever the NA options will be, the NN value will be there, this will be considered as the last rank. So the NA option is equal to bottom. So NN it is considered as a rank 5. Okay, and rank is PCT is equal to this some normalization operation is doing we are doing some normalization operation. Normalization means 2.5 divided by 4, 1 divided by 4, 2.5 divided by 4, 4 by 4. We are doing some giving some rank after that we are doing some rank normalization operation. This is the rank. After giving rank, we are doing some normalization. The PCT is equal to true, so the rank will be in the form of the normalized value like this way. So now we'll tell how we are getting the default. Max rank, bottom rank and the PCT rank we have clear. So whenever default rank is there, this I am giving doing the round of operation on the default rank for max rank. Bottom rank means whatever NA value this I am giving as the maximum rank. PCT means whatever rank values are there, you are doing some normalization on the rank value. Now I will tell how we are getting the default rank. Suppose we have organized the animals based on the minimum number of legs. The first I have written as a 2 is the minimum number of legs, 4 and the 8. Okay, so this ascending order I have stored the number of legs 2, 4, 4, 8. Okay, so after that we are giving some position for the corresponding legs. The first position, second position, third position, and the fourth position. This is the fifth position, right? So what I do is the 4 and 4 both are there in the second position and the third position. What we are doing, we are adding the positions 2 plus 3 is equal to 5 and after that we are doing the average. So whatever 4 is the second position, 4 is third position. So we are averaging the position number. Okay, 2 and 3, 2 plus 3 is 5, 5 divided by 2, 4. So this 4 is again ranked as a 2.5, this 4 again is ranked as a 2.5, then 8 is the position 4. Okay, so now I have reorganized based on the data frame values. Okay, fox 4 2.5, kangaroo 2 1, deer 4 again 2.5 rank, spider 8 and the 4 rank, and the NN is the NN only. Okay, so when you are doing the rank operation this thing is happening based on the this thing. First this is ascending order number of leg is storing, after that we are giving the position, and wherever the same values in different position are doing the average of those positions. Okay, the 2.5, and then only are giving the default rank for the same values, same number of legs. I think it is clear for you. Method I already told. Bottom also I have told. Bottom is this one is the this name, last one will be position as a last rank and n value. This is the normalization, this I've already told, the present rank divided by highest rank. So we can do some operation. So these are the some operation we can do. The data frame, some more sorting and some more things are there. Related to sorting, I have already discussed some other thing. If some other things are there, I will discuss and we will start with the next unit, the next lecture. Please like, share and subscribe my channel.